So let's just jump right in and then we'll talk about the problem of the day. Today we are talking about chapter 4.6 and it's all about decimal multiplication. Okay, and our learning goal today is to be able to model multiplication of decimals. Let's take that learning goal apart for a minute. What does it mean to model something in math? When it says model, you can automatically think in your head that it means what? Liam?
Draw.
Draw! Draw a picture that shows the multiplication of decimals. How is this the same or different than some of our previous learning goals? How is this the same or different than some of our previous learning goals from 4.2, 3, 4, etc.? Harshita?
I think in 4.2 we were doing model multiplication of decimals and whole numbers.
We were doing the multiplication of decimals times a whole number. Now, we're going to just do multiplication of decimals. That means a decimal number times a decimal number, okay? To get us warmed up and thinking about modeling multiplication, I asked you to show me in your math notebook how you can model 6 times 8 using this 100s grid. This is called a 100s grid because it is 10 squares by 10 squares. So hopefully in your book you did 10 squares by 10 squares and then you showed me how you can color in 6 times 8. There are 2 different correct answers to this problem, and let's just. All right. How can you model 6 times 8 using this 100s grid? Rashika?
You could shade in 6 sets of 8 squares.
Okay, you could shade in 6 sets of 8 squares. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I can shade in 8 and then 6 times. 1, 2, 3, 4, 5, 6. So if I colored in this section, 8 squares times 6 squares, that would show, this is 8 squares and this is 6 squares. Would this show 8 times 6? Yeah. What's another way I could show 8 times 6? Clarissa?
Well, this is just like to make it so that it's easier to see your answer.
Excuse me.
So you could color in like 5 sets of 8 squares.
3, 4, 5 sets of 8 squares. Okay. 1,
Yeah.
2, 3, 4, 5, 6, 7, 8. Okay.
And
Here's 5 times 8.
at the bottom of, wait, can I point it there?
Huh?
Can I point it there?
Yes. Show us what you mean.
At the bottom, there's still 8 squares.
Oh, so you're looking at these sets of 8, like here?
Yeah.
Okay.
So you could color that in so that it's the
Oh, so you're saying here's 1 set of 8, 2 sets of 8, 3 sets of 8, 4 sets of 8, 5 sets of 8, 6 sets of 8, it's like that?
Yeah, and you just color it.
Interesting. Okay. Could I also do it like this? Could I count 8 squares here? Oops, hold on. 1, 2, 3, 4, 5, 6, 7, 8, and 6 of those, 3, 4, 5, 6, like this? Is this also 6 groups of 8 or 8 groups of 6? Yeah. When we use multiplication, we can use an array to help us model that multiplication. What's an array? What is an array? Tanvi?
Well, it's sort of a diagram. It's basically, it has columns and rows.
Sure. So you could have 1, 2, 3, 4, 5, 6, 7, 8, and then make 6 rows of that, right? Or 6 columns, rather, like that. And if I filled this all in, that would be an array, right?
Yeah.
So just like we know that we can use an array in a diagram to model whole number multiplication, we can also use a diagram and array to help us model decimal multiplication. Okay, let's take a look. So the distance from Charlene's house to her school is 8/10 of a mile. Charlene rides her bike 7/10 of the distance and walks the rest of the way. How far does Charlene ride her bike to school? Okay, first let's figure out what is the question asking. What is the question asking, Yarden? Yeah, the question is asking how far does Charlene ride her bike to school? What is the important information we need to know to solve this problem? Liam?
Her house is 8/10 of a mile from the school.
Okay, the total distance is 8/10 of a mile.
And she
She bikes 7/10 of the way. So she bikes 7/10 of how long? Of what? How far does she bike? 7/10 of the total distance, which is what, Misaki? 0.8, 8/10. So she bikes 7/10 of 8/10. What do we know about the word of when we're dealing with word problems? Adriana? All the time. Of means multiplication. So if I have 7/10 of 8/10, how can I rewrite that as a math sentence, as a number sentence? Karan? Uh-huh. I'm finding 7/10 times 8/10. Okay. Now the next step is to draw a diagram to represent this. So go ahead and draw yourself a 10 by 10 grid in your notebook. The first thing we're going to do is we're going to deal with the first factor, which is 7/10. So let's color in 7 up and down rods to represent 7/10. 1, 2, 3, 4, 5, 6, 7. Okay, so we always are going to deal with the up and down rods first. Please point to your up and down 7 rods and show your partner that you have colored in 7 up and down rods. Partners, please check to make sure your partner is doing this correctly. Okay, now that we have 7/10 represented up and down, let's deal with the second factor. What's our second factor? The first factor was 7/10. What's our second factor in our multiplication problem? Ariel? 8/10. Let's color in 8 rods sideways to represent 8/10 like this. 1, 2, 3, 4, 5, 6, 7, 8. Again, just like before, please show your partners which 8/10 you have colored in. Then, to find the product, to find the answer, we just need to see how many have overlapped. Which ones are colored in up and down and sideways. Okay. And we know that each little box represents how much? Each little box represents how much? Liam? 100. So we have to count how many hundreds are colored in, both up and down, as well as sideways. So I have 1, 2, 3, 4, 5, 6, 7 going across, and I have 1, 2, 3, 4, 5, 6, 7, 8. So how many hundreds are in my little black box right here? 7 times 8, which is, Soham? 56. And each box represents how much? So if I have 56 boxes and each one is 1/100th, I have 56 hundredths. How can I write 56 hundredths as a decimal? Well, 0.56. So therefore, the answer, 7/10 times 8/10 is 56 hundredths. So how do I answer this question? How far does Charlene ride her bike to school? Liam?
5600.
Yep. Charlene rides her bike for 56 hundredths of a mile. Go ahead and take in your notes, write down what you need to write to explain to yourself what we did, what the process was of modeling 7/10 times 8/10 and how we found the answer. Please write an explanation to yourself of what we did so that when you look back at your notes, you'll understand what in the world we were doing. Let's take a look at the product. 56 hundredths. Is that bigger or smaller than the first factor? So we know that 56 hundredths is less than the first factor of 7/10. How does 56 hundredths compare to the second factor of 8/10? Liam? So 56 hundredths is also less than 8/10. Why is the product representing, or why is the product smaller than the two factors? Let's take a look at our model too. Let's go back and look at the model. Looking at this model, the shaded part that was shared by the top and the bottom, right? If we could see it, was it bigger or smaller than the whole grid? The product, 56 hundredths, is smaller than either factor. And it shows that in the picture too, right? The area that represents the answer was smaller than the area that represented each of the factors. Why is that? Why is that? Siddharth?
So when we're learning about multiplying a whole number by a decimal, when you multiply it by a decimal less than 1, the number gets smaller. So when you multiply a decimal by a decimal, the number will get smaller than the decimal.
When I'm finding 7/10 of 8/10, am I finding is it going to be bigger or smaller than 8/10? Because is 7/10 bigger or smaller than 1? So I'm finding a part of something else. If I'm only having a part of something else, is the product going to be bigger or smaller? If I only have a part of Quran, is the answer going to be bigger or smaller than Quran? Smaller. If I'm only going to have a part of Yarden, is the answer going to be bigger or smaller than the original Yarden? Smaller. So when you find a part of something, the answer is going to be smaller than the something that there was. And here I'm finding a part of a part, right? Because both factors are decimals. Is this factor smaller or larger than 1? Smaller. So that means it's a part, right? Is this one smaller or bigger than 1? So 8/10 is also a part of something else. So if I'm finding a part of a part, my answer is going to be smaller. Okay? And that's why the part of the model representing the product is less than the part representing each factor. Does that make sense? Very good. Okay, let's try this. We can also use this kind of modeling to represent a decimal multiplied by a decimal that is larger than 1. Okay? Remember in our previous example of 7/10 times 8/10, both factors were smaller than 1, right? Okay, so we are doing 3/10 times 1 and 4/10, right? You have 2 squares because one of your factors is larger than 1. Okay, 1 and 4/10 is larger than 1. So what I'm going to first ask you to do, I know before I told you to shade in the first factor going up and down, but right now we're going to shade in the first factor going across. We're going to shade in the second factor of 1.4 going up and down. Okay? So we're going to shade in enough columns to represent 1 and 4/10. How many tenths are in 1 and 4/10? How many tenths are in 1 and 4/10? Adam? 14. Okay, so go ahead and shade in 14 rods. Like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Even though you're coloring the whole box, make sure you're coloring up and down so you can tell which ones you did up and down and which ones you did across, okay? 1, 2, 3, 4. Now I've shaded in 14 tenths. Okay, step 2 is to shade the rows that overlap the shaded columns to represent 0.3. How many rows do I have to do 3/10? How many rows of the shaded columns do I have to shade? 3. So I'm going to go over what I shaded and do 3 rows. Like this. So I'm taking the part I already shaded before and I'm coloring in 3 rows of that. Like this. Okay, I'm not going all the way to the end. I'm only really concerned about the part that would overlap, right? How many rows of the shaded columns did I shade? 3 rows, okay, because it's 3/10. Step 3 is to count the number of squares that you shaded twice, okay? Record the product at the right. So, how many squares did I shade here? How many squares did I shade there? Stuart? 30, okay, and how many squares did I shade here? Siddharth? 12, because I had 4 rows going down and 3 this way, right? So 30 plus 12 is? So then the product is 42? 42 hundredths, because each little box represents 100.